We have 8 pairs of sample data that obtained by a student. Right, there is over here. You to summation of x. Right, there's summation of x squared, summation of y squared, and summation of x. To calculate the linear product moment correlation coefficient. So here, unlike the usual question where we have a list of data, we have a table of values in regarding x and y. Now it's slightly different. It's about they give you the sum of the data straight away. So how do we actually go about finding R where the data is presented in this manner? Alright, so honestly, some checking with the other teachers, right? This kind of question actually have not appeared in A levels for quite a few years, so we do not know. But anyway, it's still important that we know how to do it. So basically, what you do here is you have to take out your MF26. Alright, so MF26, there's actually we need to determine the equation of the least square regression line of y on x and x on y. So how do you go about doing this? Third formula that's presented as follows. Alright, so if you observe in MF26, you use the formula for MF26 where R is given as the summation of xy minus summation of x summation of y over n over the summation of x square minus okay, and this one. Okay, alright, so this is the formula from MF26, and that is basically what we will use here. Alright, so what is the summation of xy? So we're just going to plug in term by term. Summation of xy as given will just be from the data. This is 3985. Summation of x is 360 again from the question. Alright, this is the question. This is just the question value. Alright, here I'm just using the MF. So I'm just using it to find my R sincerely and honestly. 140. And what's my n? Remember we were talking about 8 sets of data. So n is equal to 8. And it's 8. Summation of y is 140. I mean, I'm just being very really slow and step by step here. Okay, so I mean, if you find me very boring, you can actually fast forward and just ignore this part of the video. Alright, so square again, this is 8. Summation of x square 21830. Alright, so just key in, just plug in all the values carefully. R, your R has to be hopefully okay somewhere within the expectation. Alright, calculate the linear product moment correlation coefficient for this data, and if all goes well, come out to be eventually hopefully your R after substitution should be equal to 0.952. Alright, so this suggests, what does this suggest? The next question is about the relationship between x and y. So since absolute value is rather close to 1, it does suggest that between x and y have a strong negative correlation, right? Because it's negative and it's close to 1, has a strong negative linear correlation. Alright, linear correlation. Alright, so this is for the first. So we need to determine question probably. Alright, the formula actually is over here. Answer should part. We need to determine okay, so back to the question. Even use the GC. We may even touch it. So I'm just going back to the MF26, right? So this picture here, alright, this is from the MF26. Alright, this is from the MF26. Alright, where we have the estimated regression line of y on x to be defined as y minus y bar, right, equals to b x minus x bar, where b is the summation of x minus x bar, y minus y bar over the summation of x minus x bar square. Alright, and over here, I hope you also could have studied about this. If you can not sure, you can actually go and read the lecture notes that this is actually equals to the what we call covariance of xy. Alright, the top is actually the covariance of xy over the bottom, which is just the covariance of x. Alright, and what is b? So okay, in fact, b itself, because it's just a summation of x minus x bar, y minus y bar, summation of x minus x bar square. Okay, you can also say, okay, very quickly, I'm just going to show you a portion if you're stuck here, I'm just going to show a portion of the lecture notes. This is from the lecture question. This is from the lecture question. Alright, so this is basically telling you that the proof was from the appendix in the lecture notes, that this portion over here, right, based on this portion, you can say that the summation of x minus x bar square is just the summation of x square. So this is another way of relating. I mean, I'm just going to quickly go through this part so you understand that, you know, basically this is the bottom part. This is the bottom part. Alright, the top portion basically is the covariance of x, and the covariance of, the covariance of xy also, alright, the proof actually can be found in the comprehensive notes. So this is from nothing but the comprehensive notes or lecture question, the appendix. Okay, so you can just look at the appendix portion in the correlation regression. Appendix A, if I'm not wrong, alright, is under the page 27, page 26 out of 27 of your lecture notes. Alright, so I'm just going to repeat this part. This is mainly what we call the covariance of, alright, xy. This is what we call the xs of xy, or we call it the covariance, right, of xy. Right, so if you don't understand what it means, it doesn't matter. But at least you know that that is the existence of this term. Right, so basically from there, I'm just going to tell you that this portion here, right, is nothing but the summation of xy minus the summation of x, the summation of y over n. Right, so this itself, again, you got to know what it is. You got to know, because that's the portion that's not really in the MF26. Right, so the only thing that's inside MF26 is this one. Oh, this one. Okay, this one. So here you can see how B here, okay, B here in fact can also be rewritten. Okay, B here can also be rewritten as the summation, because this portion here, right, was a covariance. So actually just basically xy minus summation x summation y over n over the summation of x square minus the summation of x whole thing square over n. Alright, and from here, okay, we're just going to go about solving this. Alright, so we were looking at the question just now, but so we're going to use this portion. So we're going to use the regression line. Let's just find the regression line of y on x, alright, from MF26, alright, is just equals to y minus y bar equals to b of x minus x bar. Alright, so how do we go about finding this? Number one, our y bar here would just be the summation of y over n. Alright, so our summation of y, what's the summation of y? Based on the question, it's just equals to 140, and y is n is just 8. Summation of x, based on the question, it's just summation of x over n, which is the summation of x for the question is just 360, and n is 8. We also are talking about 8 pairs of sample data. Okay, and how about b? Alright, b would be nothing again but the covariance of xy over the covariance of x, alright, which is the summation of xy minus the summation. So I say again, if you didn't catch what I was saying just now, this portion here, alright, can be gotten from the MF26, or you can read the appendix of the lecture notes, comprehensive lecture notes, to know more. Alright, okay. Oh, sorry, let me just okay, let me just rewrite this portion again to make it clearer. Alright, over the summation of x squared minus the summation of x whole thing squared over n. Alright, and we're just going to put in bit by bit what we saw in the question. Alright, so very quickly, I'm just going to to now find, remember just now we were doing the regression line of y, regression line y on x, right? Then the equation was to have y minus y bar equals to b x minus x bar, all right? And b originally was equals to the summation of xy over the summation of xx. This was the regression line of y on x. So now we are doing it the other way around. Basically, we're going to do x on y. So how do you go about doing this? Basically, what we do is we still use the same equation. Basically, what we do is very simple. We just exchange the variables. We just swap y for x, and we replace x with y. All right. So if you notice, right, this is from the MF26. I'm just going to use this formula, and the thing now we put y as x. We are going to exchange. We are do x on y instead. Okay, so y is going to be x and x is going to be y. So what I'm going to do is okay, I'm going to change all the y to x. This is going to be x. This is going to be x bar. This is x minus x bar. All right, and all the x will now be y. So this is going to be y minus y bar. And b over here. All right, so because y is being swapped with x, x is going to be swapped with y. This is going to be y. This is going to be y. You can see that this b is now different from the original b, so we can't use the same, so I'm going to use it as a b prime. All right, so basically my new equation is x minus x bar equals to b prime y minus y bar. This is the regression line x on y. Okay, it's slightly different from y on x because now x and y have a so-called swap place. Then your b prime is just a covariance of xy over the covariance of yy. Unlike the original, which is y on x, in your MF26 the formula is given regression line y on x. Now we are doing x on y. Okay, so we can do this easily, but all we need to do is just swap variables. We replace all the x in the formula list with y, replace all the y in the formula list with x. All right. Okay, with that we can now use this formula to compute and get the regression line of x on y. So how do we do that? Okay, very simple, right? So x minus x bar. Okay, so x minus x bar again. X minus x bar equals to b prime y minus y bar. We're just going to use the same CD idea. So x bar, as we found, was summation of x over 8. This is the summation of y over 8 because n is equals to 8 in this case. This b prime will just be the summation of xy over the summation of xx, alright, which is basically the summation of xy minus the summation of x summation of y over n over the this is not, sorry, this is yy, not xx, okay, over the summation of y square minus summation of y square over n. Alright, so showing you the data values again.